So let us continue with our question. In the first tutorial video for this question, we covered 1.1, which involved factorizing expressions. As previously mentioned, in this second video, I will be going through the rest of the questions. So 1.2, which is simplification of expressions, and then I will also try to squeeze in 1.3 while keeping the video as concise as possible. So let's get into it. So again, the instruction here is simplify the following expressions fully. So we need to simplify fully. And 1.2.1, we have open bracket x plus 2 into open bracket x squared minus x plus 3. And in order to simplify this expression, we need to start by expanding it. Whenever you are given an expression in this format and you are being asked to simplify it, you must know that you most definitely need to remove your brackets. And in order for you to remove the brackets, you need to expand. And so basically, expanding is the opposite of factorizing, which is what we were doing in the previous question. So in order for us to expand this, we need to multiply x by x squared, okay, in the second bracket. And so this will be equal to x to the power of 3. And you can use laws of exponents to get that. So if you are multiplying x by x to the power of 2, the laws of exponents tell us that in multiplication, if the bases are the same, just like in this case, you take down that base and then you just add the exponents. So our exponents are 1 plus 2 because the exponent here is 1. And so this will be equal to x to the power of 3. And then we also need to multiply that x with negative x. And so negative x multiplied by x, again using laws of exponents, this will be negative x to the power of 2 because you will add the exponents here, which is 1 plus 1. And then since the signs are not the same, you will get a negative answer. So we get here negative x to the power of 2. And then we multiply x by positive 3, and this will be simply be equal to 3x, okay? And then we need to do the same thing, but now with positive 2. So we multiply 2 with x squared, and this will give us positive 2x squared. Okay, so let me remove this to make some room. And then after that, we multiply 2 by negative x. This will be negative because we're multiplying a positive term with a negative term. And then 2 multiplied by x is just 2x. And then lastly, we multiply 2 by positive 3, and this is positive 6. Okay? And thereafter, what you can do is you can check whether or not you have some like terms. So let me move this downwards slightly. And so starting with x to the power of 3 here. So we are just going to write it down and then see if we have a term here that has an exponent of 3 for x. And there is no term like that. So x to the power of 3 does not have a like term. And then we have x to the power of 2, and then we need to search whether or not we have a like term of x to the power of 2. And its like term is going to have the same exponent in the variable x. And if you search for such a term, you'll find that 2x squared will be that like term. And that is because both of these have the variable x and it has an exponent of 2. So they are like terms. So let's write them next to each other. Okay, and then we have plus 3x, and again, following the same procedure, we check for a like term of 3x, which is going to be minus 2x, because you have x and you have x, and they are both to the power of 1. So those are like terms. And so we are going to write minus 2x next to 3x. And then our last term is positive 6. And then after this, we can then combine our like terms. And so here we have negative x squared plus 2. And you must note that because of the commutative property of addition or subtraction, we can also write this as 2x to the power of 2 minus x squared, because the order does not matter. So for some people, it may be easier to combine these if you write them like this, as opposed to when you are reading the terms like this. So if you find it tricky to combine terms whereby they are written like this is what you can do. But of course, besides that, you can just simply use your calculator to find minus 1 plus 2. Okay, and so minus x squared plus 2x squared, or 2x squared minus x squared, is going to give us 1x squared. And in algebra, we do not write a coefficient of 1, so we can just write plus x squared. And now moving on to the next set of like terms, here we have 3x minus 2x, which is going to be equal to plus x. Okay, and then we can just carry down the positive 6. And so this means that this is our fully factorized expression. Okay, and so let's move on to the next one. I'll just move this to the side. And so in 1.2.2, we have an expression 5 over x plus 3 minus 3 over 2 minus x. Okay, and this time around, the terms in our expression are written in a fraction. Okay, and so this means that for this question, we need to apply our knowledge from addition and subtraction of fractions. And so what you need to know here is that if, for example, you have a fraction of a over x plus b over x, in order for you to combine these fractions, you just need to find the lowest common denominator, which would be x in this case, because x is common in both of our terms or fractions. And so the result of this addition would be a plus b divided by x. But now, there are situations whereby the denominator is not the same. For example, if the denominator for the second fraction is b over y. And so in a case like this, there is a trick that you can do in order to make these denominators look the same, so that you have a lowest common denominator. And so basically what you can do is you can take the first term as it is, and then you are going to multiply the numerator and the denominator of this fraction by the denominator of the second fraction, which is y. So you are going to multiply a by y, and you also multiply x by y here. And the reason you can do this is because if you multiply the numerator and the denominator by the same number or by the same term, it does not change your fraction, because y divided by y is equal to 1. So this is as if you have multiplied your fraction by 1, which does not change anything. In other words, this y here can cancel with this y, so that you are left with the same fraction as before. And so we then go on to the next fraction. And we are going to do the same thing here, but this time around, we are going to multiply the numerator and denominator of this fraction by the denominator of the first fraction, which is x. So we multiply b by x, and we also multiply y by x. And again, this is like multiplying this fraction by 1, because x divided by x is equal to 1. So this does not change the fraction. And now, once you do this, you end up now with the same scenario as the first one that I showed you, which means that you can simply do your addition of the fraction by saying a multiplied by y plus b multiplied by x, all of this divided by the lowest common denominator, which is x multiplied by y. And of course, you need to remember that x multiplied by y is the same as y multiplied by x because of the commutative property of multiplication. So the order at which you multiply the numbers does not matter. And so this is the trick that we are going to employ in order to answer this question. Okay? And I'll just remove it so that we have enough space. And so here, and so even here, we are going to say that this is equal to 5 over x plus 3. And of course, when you are answering your question, you need to start by copying it down as it is. And then we do our trick. And so we are going to have 5 multiplied by 2 minus x. And then here, in order for us to multiply x plus 3, since we have two terms, we need to put them inside brackets. And then we multiply by 2 minus x. And again, I hope that you can see that this is like multiplying by 1, because 2 minus x divided by 2 minus x is equal to 1. But we need to leave it like this. And then after that, we minus 3 over 2 minus x, and then we are going to multiply the numerator and the denominator of this fraction by the denominator of the first fraction. So we multiply 3 by x plus 3, and then we need to put 2 minus x inside the brackets, and then also multiply it by x plus 3. Okay? And now, after doing this, as you saw in the example that I showed you, we can simply say that this is equal to 5 into 2 minus x minus 3 into x plus 3. All of this divided by the lowest common denominator, which is x plus 3, all into 2 minus x. And of course, if you like, you can also write this as 2 minus x into x plus 3, okay? And then, of course, the step after that is you need to expand your terms that are in the numerator and then add any like terms that are available. So we are going to multiply 5 by 2, and this is going to be 10. And we also multiply 5 by negative x, which is going to give us negative 5x. Okay? And then we need to multiply negative 3. Remember that this negative here is the sign of this whole term. So we need to multiply negative 3 by positive x, and that is going to give us negative 3x. And then we need to multiply again negative 3 by positive 3, which is going to give us negative 9. Okay? And then for now, we can keep our denominator as it is. So we still have x plus 3 into 2 minus x. And so now I am just going to skip that step whereby you are grouping your like terms next to each other. What is important is for us to see that 10 has a like term which is -9, and 10 minus 9 is going to give us 1, okay? And then we also have -5x and -3x as our like terms. And so -5x minus -3 is going to give us -8x. And then we need to divide all of this by x plus 3 into 2 minus x. And there is nothing more that you can do after this, unless we had some common factors in the numerator as well as the denominator. So this would be our fully simplified expression for 1.2.2. Okay. And now the next question, which is also the last question for 1.2, we have 25 to the power of -x. In fact, we are supposed to have a division here. So this is a fraction. So here we have 25 to the power of -x multiplied by 15 to the power of x plus 1, because that's what that dot represents there. It represents a multiplication. And so that divided by 3 to the power of x multiplied by 5 to the power of -x. And for this one, you need to know your laws of exponents. Okay? And so what we can do here is you need to start by noting that 25 is equal to 5 to the power of 2. So we can write that 25 here as 5 to the power of 2, or 5 squared, okay? And so that 25 had an exponent of -x. So even this 5 to the power of 2 must have that exponent, okay? And so what we can do for 15 to the power of x plus 1 is we can use the product law of exponents, which is that in multiplication, if the bases are the same, so let's say for an example, you have a to the power of y multiplied by a to the power of x. This is equal to a to the power of y plus x, okay? And I'm sure you remember because we have spoken about this law already. So what we can do is we can make use of this law, but this time around are going to apply it in this direction, because we have an exponent here which is written in this form. So what we can do is we can write it in this form, okay? So we are moving from the right hand side to the left hand side, okay? So this means that 15 to the power of x plus 1 can be written as 15 to the power of x plus 15 to the power of 1, which is of course just 15, okay? And this is based on this law. And now we can go to our denominator, and there we have 3 to the power of x, and there's nothing we can do with that at this point. But we also have 5 to the power of -x, okay? And now after this, what we need to do is we need to remove these brackets here. And again, we are going to do that using the laws of exponents, which tell us that whenever you have something like this, you can write it as 5 to the power of 2 multiplied by -x, okay? And so, of course, 2 multiplied by -x would just be simply equal to -2x. So I'll just write this as -2x, okay? And then we will still multiply by our 15 to the power of x multiplied by 15 and divide this by 3 to the power of x multiplied by 5 to the power of negative x. And now, the first thing that you need to recognize after this step is that in the numerator here, we have an exponent which has a base of 5. And in the denominator, we also have an exponent which has a base of 5 as well. So again, we can apply the laws of exponents, okay? And the division law, which tells us that in division, if the bases are the same, like in this case, we can just write 5, which is our base, and then we take the exponent of the numerator, and from that we subtract the exponent of the denominator. So we subtract negative x, so that's why I am including the brackets here for the negative x. And then we are still multiplying this by 15 to the power of x and 15. And then we need to divide this by 3 to the power of x. Remember that we have divided 5 to the power of negative x to 5 to the power of negative 2x. And now, after this, what we need to do is we need to simplify this exponent here of 5. And so here, what you need to recognize is that we have 2x minus into minus x. And so this is equal to negative 2x. And so negative multiplied by another negative is positive. And so we have positive x. And then you can see that negative 2x plus x, these are like terms, and this will be negative x. Okay? And so here for 5, we are now going to have an exponent of just negative x. Okay? And after that, we multiply that by 15 to the power of x multiplied by 15. All of this multiplied by 3 to the power of x. And now, what can we do from here? Let us see. And so here it's clear that we need to do something in order for us to be able to do any further simplification. And so we are going to do another trick. And here is this trick. We have this 15 to the power of x, right? So what we know is that we can actually write 15 as 3 multiplied by 5. And then since the 15 has an exponent of x, we are going to raise it to the power of x. And now, if you do that, I'm sure you can already see that what we are going to end with is that, again, using the laws of exponents, it means that we can write this as 3 to the power of x multiplied by 5 to the power of x. Okay? And so this 15 to the power of x can be written like that. And in fact, this is something that you can do earlier during the calculation. If I had noticed it early, I would have done it immediately in the first step here, okay? But I only noticed it now. So then I am going to write 15 to the power of x like this. And so in place of 15 to the power of x, we are going to have 3 to the power of x multiplied by 5 to the power of x multiplied by 15. And then we divide all of this by 3 to the power of x. And now all of these numbers or exponents in the numerator have a multiplication sign between them. So this means that we can cancel this 3 to the power of x with this 3 to the power of x. And now in addition, you will notice that we are now going to be left with 5 to the power of negative x multiplied by 5 to the power of negative x, and of course the 15, right? But now these ones have the same base, so we can apply the laws of exponents to combine them. And if we do that, we will get 5 to the power of negative x plus x. And negative x plus x is going to give us 0. So this will be 5 to the power of 0. And in mathematics or in algebra, we know that any number that has an exponent of 0 is equal to 1. And so we can do exactly that with 5 to the power of negative x and 5 to the power of x. So basically, this is just going to cancel with this one, so that you are left with 15. So the final answer here is 15. And of course, when you are answering this question, you can rather show this in one of your steps. And so now let's move on to the last question. And so the last question here, 1.3, is determine the value of 3p plus q all to the power of 2 if 9p squared plus q squared is equal to 12 and pq is equal to negative 3. And so basically the trick in answering this question lies in you knowing how to expand this expression here. And so we have 3p plus q and all of it to the power of 2. So there are two ways on which you can do this expansion. There is a long way, which is what you essentially can do is recognizing that this is equal to 3p plus q multiplied by 3p plus q. And then you just need to expand as you would normally do. So 3p multiplied by 3p, 3p multiplied by q, q multiplied by 3p, and q multiplied by q. And then after doing that, you'll need to add the like terms that will be available. Or alternatively, a shortcut of doing this is you just find the square of the first term here, which is 3p. So what is 3p all to the power of 2? Well, 3p all to the power of 2 is going to be equal to 3 to the power of 2 multiplied by p to the power of 2. And so 3 to the power of 2 is equal to 9. So this will be 9p squared. And then after that, in order for you to find the middle term, you simply need to multiply the two terms here that are inside the brackets. So you will say 3p multiplied by q. And after that, you need to multiply all of this by 2. And so we have two numbers here, 3 and 2, or two coefficients. So 3 multiplied by 2 is going to be equal to 6. And then you will have pq, because p multiplied by q is just pq. So it means that the middle term here is going to be 6pq. And then you simply need to find the last term, and that last term is going to be given by the square of q here, or the last term inside the bracket. So that will simply be q to the power of 2. Okay? And then note what they told us here in the question. They told us that 9p squared plus q squared is equal to 12. And we know that, again, because of the commutative rule of addition and subtraction, the order does not matter, so we can group these terms, or we can change the order of these terms into 9p squared plus q squared, and then we carry down the 6pq. Okay, And so now you will recognize that we have here 9p squared plus q squared, which we were told in the question or in the statement that it is equal to 12. So this here, so this means that these two terms here, we can replace them with 12. And then we were told that PQ is equal to -3, okay? And here we do have PQ, right? And we are told that the PQ is equal to -3. So this means that we will say plus 6. And then in place of PQ, we can substitute in -3. And therefore this will be 12, and then 6 multiplied by -3 is going to be -18. And therefore our answer is going to be 12 minus 18, which is going to be equal to -6. So the final answer here is -6. And so there you have it. This is how you can answer or tackle these types of questions. And so I hope that you enjoyed this tutorial video and that you have learned something from it. If you have watched the video up to this point, shout out to you. For me to recognize you, please just leave me a comment down in the comment section below, and also don't forget to like the video. And if you haven't done so already, please also become part or a member of this channel by pressing the subscribe button. I hope to see you on the next one.